Xman, Extended Arrival Management. As an answer to the increasing demands placed on the aviation sector, the European Commission launched the Single European Sky Initiative. One of the first steps was to create functional airspace blocks. One block is called Fabec. Fabec incorporates the airspace of Belgium, France, Germany, Luxembourg, the Netherlands and Switzerland. Our air traffic controllers guide more than 5.5 million flights per year. This includes en route traffic towards the Atlantic or the Middle and Far East, as well as a large number of feeder flights to hubs in Europe. This makes Fabec one of the most complex and busiest airspaces worldwide. 3 out of 4 of all controlled flights depart or arrive from one of the airports located in Fabec airspace, such as Paris, Frankfurt, Amsterdam and Munich. Furthermore, the airports of London are located nearby. Our British colleagues are making important contributions to the Fabec Xman project. Due to increasing air traffic demand, major hubs are operating close to the capacity limits of their runway systems. If this capacity experiences additional temporary limitations, for example due to bad weather, or if there are just too many aircraft approaching an airport at the same time, this results in holdings and longer flight routes. This causes more fuel burn, emissions, and costs for the airspace users, the airlines. To prevent this situation, arrival management systems are in place at many international airports. Based on the actual positions, flight paths, and speeds, these systems calculate the point in time an aircraft flies over designated waypoints and the runway threshold to obtain an optimal approach sequence for all aircraft. The air traffic controllers controlling the en route sectors instruct pilots to speed up, slow down, or extend their flight path so that they can be handed over to the approach controllers at the calculated time. This provides the approach controllers with pre-coordinated and synchronized arrival flows from different directions and creates a consistent arrival flow for maximum runway throughput. Today's arrival management systems only operate out to a distance of about 80 to 100 nautical miles around an airport. This works out to be about 20 minutes flying time before landing. This short window of time limits the number of possible corrective actions, and there may still be holdings if the calculated times cannot be met otherwise. Extended Arrival Management. To overcome this limitation, Extended Arrival Management expands the planning horizon of arrival management systems horizontally to at least 200 nautical miles from the airport. Vertically, this includes the top of descent, the point where the aircraft leaves its cruising altitude. The time window in which inbound traffic can still be influenced is thus increased to a period of 40 to 50 minutes before landing. This means that the alternatives for coping with arrival constraints are much greater and require only slight tactical actions in the en route phase. En route air traffic controllers in charge of aircraft 200 nautical miles from the airport are now provided with early information about the arrival situation at the destination airport. Using the predicted situation, controllers are advised whether to let the aircraft proceed as planned or to start slowing it down to position the aircraft properly in the arrival sequence at an early phase. Applying a speed reduction at this early stage may help to avoid holding patterns or extensive flight path stretching close to the destination airport. The key factor for the success of the extended arrival management system is close collaboration between air traffic control units, regardless of location, organization, or national borders. The implementation of extended arrival management is being carried out in phases. The first initial implementations are already in place for flights to Munich Airport, controlled by Vienna Area Control Center, ACC. For flights under the control of the Fabec Upper Area Control Centers, UAC, in Maastricht and Reims, heading to London Heathrow. For flights to Amsterdam Airport, descending from the airspace of Maastricht UAC, for flights controlled by Paris ACC to Paris airports. By 2018, the following systems will be in operation: for flights to London Heathrow, controlled by Brest ACC; for flights to Frankfurt Airport, under the control of Maastricht UAC, Karlsruhe UAC, Munich ACC and Bremen ACC; for flights to Munich Airport, controlled by Karlsruhe UAC, Zurich ACC, Prague ACC and Langen ACC; for flights to Zurich Airport arriving via the airspace of Reims UAC, Munich ACC and Langen ACC; for flights to Nice and Lyon airports controlled by Marseille ACC. Towards the end of the decade implementations, for flights to Brussels controlled by Maastricht UAC and Reims UAC will follow. Further steps are scheduled for the airports of Amsterdam, Berlin and Düsseldorf. To synchronize arrival flows in a balanced way, it is crucial that the extended arrival management covers all inbound flows from all directions. Xman will also affect neighbouring en route control centres outside Fabec. Not only does the extended arrival management system allow the optimal use of restricted physical runway capacity, experts also calculate overall annual savings of up to 64,000 tonnes of fuel. This means that CO2 emissions from aircraft will be reduced by up to 215,000 tonnes. Fabec. We are working together to keep the skies safe.